Okay. Good morning, gentlemen. Today is, I don't know what today is. There we go. Today is April the 23rd, Thursday. And today we are going to talk about the third and final lesson in our very quick unit on magnets and magnetism. This section is entitled Magnetic Forces. Now, obviously, if you've ever played with two magnets and tried to either push them together or pull them apart, you've experienced a magnetic force. All right. If you try to put two north poles together, uh, they will repel. And no matter how hard you push, they push each other back and away from one another. Only a north and a south will attract. All right, this is very similar to what we see in electric forces, where a positive and a negative charge will attract, but two positives will repel and two negatives will repel. All right, in this case, two norths will repel, two souths will repel, but a north and a south pole magnet will actually come together. They'll attract one another. So, what can we determine about these kinds of things, especially when we combine this with the idea of a conductor carrying electrons from one place to another? And so, this is where we are with magnetic forces. This is what we're going to talk about today. When a current carrying wire is placed in a magnetic field, a force is exerted on the conductor, the wire. Okay. Uh, but this is if and only if the conducting wire, that's IFF, you should know that from math, I think, I hope. But IFF is if and only if the conducting wire is not parallel to the magnetic field. Okay? So if the magnetic field is going left to right and the conductor is going left to right, there's no magnetic force. But if they are at any angle to one another, a force will be applied by the magnet on the conductor. Okay. So, how do we determine what kind of force that will actually be? Well, in order to do this, we go back to our handy dandy left hand rules. And we'll start with the third left hand rule. Okay. If an outstretched hand, all right, you got to use your left. All right. If an outstretched hand is placed on a current carrying wire in a magnetic field such that the thumb, there we go, such that the thumb points in the direction of the electron flow and the fingers point in the direction of the magnetic flux, the palm will face in the direction of the magnetic force. So here is, I don't know why it does this, but let's say this is a current carrying wire. Okay. And just for the sake of argument, we'll say that the electrons here are flowing from bottom to top. And at the same time, we're going to place this thing in a magnetic field. So here's the flux lines of this field. Now notice these are all going in the same direction. Okay, and you can draw the rest of these in your notes or whatever, but you get the idea. So how does this all work? Well, remember that the X represents a field line going away from you. So in this case, you would have to take your left hand and point it directly at the screen of your computer or your phone or whatever it is, right? So right into there, because it's going to go away from you, all right, the magnetic field. And the thumb is pointing up, all right, because the direction of the current is up, all right? Your palm, which is here, all right, the palm of your hand, will face in the direction of the magnetic force. And so if you look at this very carefully, come on, what's the direction of the force? It will be this way. All right, that will be the big old magnetic force. Okay, that will be the big old magnetic force traveling. So the wire will be pushed toward the left side of your screen. All right, think about this again. The fingers are pointing into the screen. The thumb has to be pointing upward, and therefore the palm faces toward the right side. Did I say left? It should point toward the right side of the screen. And so the wire will be pushed toward the right. Okay. Now I'm thinking I said that it was pushed toward the left, but I do know my left from my right, I promise. All right. Now, so in terms of these forces, what exactly, how can we do this? Well, if we're looking at let's first of all, before we do that, let's do another example. Let's say this is my wire, and there's the electrons. They're pointing out at you, all right? And so in this case, the thumb would have to point, here's my thumb, the thumb would have to point directly at you because the electrons are heading directly toward you. Now, let's say that the magnetic field lines are going this way toward the left, or right rather, I did it again, toward the right. In this case, the what's going to happen to the magnetic force? Well, the thumb's pointing toward you. The fingers have to point toward the right side of your screen. What direction is your palm facing here? All right, well, if you think about it, it's fairly straightforward. Your palm is pointing downward, and so the force being applied to this wire is down. Okay. All right. Now, another interesting aspect. All right. If you have two current carrying wires that are parallel to one another. All right. And so here's one. Here's another. Okay. Remember the first left-hand rule, which says that the thumb points in the direction of the electron flow, and the fingers will curl around the wire, such as looking like this. All right, and the same thing is going to be true here. What will happen if these two wires are really laid next to one another is that they will be attracted to one another, and that you will end up forming one big magnetic field around the whole kit and caboodle. But on the other hand, if I have one wire where the current is flowing into the screen and another wire where the current is flowing out of the screen, well, here the magnetic force is going counterclockwise, but here, whoops, it's going clockwise. I'm sorry, I'm drawing this with a mouse. It's not an easy thing to do. But in this case, what's going to happen is that the two wires, the magnetic force lines, the field lines, will push out and away from each other.
It's 3 o'clock.
So what eventually will happen in this case is that this wire will go off this way, and this wire will go off this way. They won't actually be attracted. They'll be repelled from one another. All right. So if the two wires have current flowing in the same direction, they'll be attracted to one another. They'll stick together. And if they have current flowing in opposite directions, they will move away from each other. They'll be pushed apart by the magnetic forces. All right. So this is the end of our little discussion of magnetism, although we're going to kind of combine more electricity and magnetism in the next unit. There is no homework for this unit, and I'm not going to quiz you on this. Usually I give a quiz with 10 different drawings of these kinds of drawings that you see here, and ask everybody to use the left-hand rules in order to figure out forces and current flow and that sort of thing. And it's a very fun quiz for me to watch because every student is contorting their arms and everything else. But unfortunately, I'm going to have to miss that this year. But that is magnetism. And on Monday, we'll talk about our next unit. Now, today is Thursday, which means that tomorrow is Friday, And gentlemen, of course, on Friday, you have a quizzy do. Therefore, please make sure that you are ready for your quiz. You will have one question on series circuits and one question on parallel circuits on tomorrow's quiz. All right. Have a great day, and I will see you tomorrow. Bye.